الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Hello, good evening, and welcome to our third session of the Best Emirates 2021. Already have two sessions, Developers Best Festival. So we're switching attention to a completely different topic now. We had two great topics to start with. One on soft skills. We moved on and talked a little bit about machine learning. Now we're going to talk about a bit of security on our third session, which is about protecting against data exfiltration with VPC Service Controls on Google Cloud. So 3 topics we're going to cover just to set the scene, understand what VPC Service Controls are all about. Going to talk a little bit about security on Google Cloud, how Google they approach security, what are the services that are provided in there, what is it as a cloud provider that is already for us there without need to worry about those layers of security that Google taking care of, and what are our responsibility as customers or as users of Google Cloud that we should take care of. And then we will talk about networking security, and then we'll bring in the topic of VPC service controls at the end. So Google's approach to security, when we look at security in general in the cloud, it's a collaboration. It's a shared responsibility. So if you are working on-prem, on your own data center, security layers or the security stack, you are all responsible for all the security stack from the lower layers, from the physical data center itself to the hardware, to the networking, encryption, all those kind of stuff. When you move to the cloud, the responsibility is shared between you and the cloud provider. In our case, is Google Cloud. So the infrastructure itself, the physical security of the hardware, the premises of the data center, the encryption of data, integrity of the network, security of the content as well. Some of it will be responsible of Google. So that's the lower layer of security that all of it is taken care of by Google for you. And this works at scale. We're not looking at one location, but if you have an application that is globally available, globally distributed, all those lower layer sets of security is taken care for you by Google. The upper layer, which is anything that you see in blue of the security stack, this is what remains the customer security. This is your responsibility if you have any applications, if you have any data, if you have any services that you're running. And it will depend on the service that you're using. So you can see in there, what you see is we have infrastructure as a service, things like virtual machines. So virtual machines, Google give you the VMs. It will be your responsibility to install the software, to patch the software, the application. So anything that comes on top of the storage encryption, the host where these VMs are created, all those the lower level is the Google responsibility. The higher level, the operation that you're going to do, the backups, the application you're going to install, that's all going to be your responsibility. The more you're going to move into what we call platform as a service, software as a service, serverless services, managed services, The responsibility of the customer is less, and more is taken by the Google Cloud provider. So if we take, for example, a deployment execution environment like App Engine, for example. So App Engine is a platform as a service. Most of the security stack in there, it's a responsibility of Google. So the responsibility of a developer is they deploy the code into that service, and they just manage the code. Anything else is managed for them by Google. You move to things like Cloud Run, you move to something completely serverless, things like machine learning APIs, you move to things like PubSub, for example. So all those serverless services, the real responsibility is the data itself. The governance of that data, who do I need to give data to? Who is responsible of being able to change data, edit data, or just read only data? So this is kind of the layers of the different services that you have in there. And having said that, when we say Google give you responsibility to manage your data and give access to that, we're not saying that Google turn around and say it's your responsibility, we don't care how you do it. Rather, they give you the tools to do that within GCP. They give you the best practices to follow, and so on and so forth. So for data access, for example, when we get data to a service like let's say cloud storage, and as the storage aspects, it's completely service. We know that cloud storage, it's elastic, whatever data you can put in there, but it's your responsibility to control who have access to that data. And Google give you things like what we call cloud IAM, identity and access management, to secure your what we call storage buckets, but also gives you another tool if you want to more granularity into the object that I'm storing in cloud storage, which is ACLs, access control lists, and anything that you made to request from to cloud storage, for example. It's kind of an API call, and when those calls you make them, they always must be authenticated. They must be authorized with what kind of permissions I'm giving to that API call, whether it's coming from an application, whether it's coming from a user requesting data from cloud storage bucket. So you won't be able to make any unauthenticated call to cloud storage, unless if you're making data publicly available. So you don't need to authenticated users to access your data. So when we talk cloud IAM, this is the mechanism that Google gave us to access our data, identity and access management. It's about three kind of components: who, the person that needs to access, whether it's an application, whether it's a VM, whether it's a user or a group. It can do what, which is basically what kind of permissions I'm going to give to that person or to that identity to do a particular task, and then apply it to a resource. So on which resource I'm giving this set of permissions for that user or for that group, for that identity, in order to do a particular task that they require on that service. So these kind of three components which constitute what we call an IAM policy. It's a binding between a user on identity with a set of permissions, and then apply them to a resource. When we talk about resources in GCP, we've got what we call resource manager. So the resources in GCP are distributed in what we call a hierarchy. A hierarchy what comes with an organization that comes at the top. The organization represents your company, it represents your organization. And in there, you can create what we call folders. And folders is a segregation of resources based on maybe some kind of legal entities, departments, teams, environments. So you can divide all your resources inside those folders. And inside the folder, I can create a project. Now, the project, this is the main component of this resource hierarchy. This is where I'll be able to create resources. This is where I get billed for those resources. So if I'm creating a VM, if I'm creating a storage bucket or a database, I won't be able to create it under a folder or under an organization. It has to be under the project. So this is the component where I can enable APIs, create resources, and then inside there, I can create my whatever services I need to leverage on GCP. So all those, what we call IAM objects, constituting the hierarchy. Plus, then I've got those members are then to give permissions to in what we call roles. So the roles in GCP, I won't be able to give permission directly to a resource. It's basically a set of permissions that are kind of gathered or kind of combined into what we call a role. And in GCP, we've got three different types of roles. We call what we call primitive, we've got predefined and custom. Primitive roles are very, very broad. I can apply them at the project level. So I can say, okay, I've got a project owner who would be responsible for all the resources, got access to everything. Or I can get an editor, somebody who can have editor role, editor permission to all the resources in GCP. And you get a viewer role, somebody who's got read-only access to all the resources to a project. You can see by saying that primitive or basic, this one kind of, I won't be able to apply them in a production environment because an editor role could be so powerful. Can be if you give it to the right identity, for example, or somebody who's not what they're doing, they can delete a lot of resources, they can add a lot of resources. So from security perspective, it's not best practice. From cost as well. So you're giving kind of so powerful kind of permissions to different people on a whole project. And for that particular reason, Google, what they done, they came up with this what we call predefined roles. So predefined roles are, no matter what service you are using in GCP, Google have created this set of permissions for each of these roles. Let's say I've got BigQuery, for example. I can assign somebody from my data analytics team to be responsible on BigQuery. So I can say BigQuery admin. Within his team, I might have somebody who's just want to read the data. So I can get BigQuery with read permissions. So there's a predefined role with that. Or somebody who just want to be responsible for connecting sources of data from outside GCP. So I can be somebody responsible for that. So each service has got a set of predefined roles that I can use. So basically using what we call the least privilege concept in here. So just giving the right permissions to the users, don't give them more than they need. But in some instances, even the predefined roles, in some companies, there are some security restrictions in there. For instance, if you have a permission to delete resources, you don't want anybody to be able to delete resource except for a particular team. Now, there isn't a particular predefined role with a permission without delete, for example. So this is where I want to create something custom from this predefined role, select just the permissions that I need, and I create custom roles, removing the permissions that I don't need from there. So this kind of this IAM roles, that part of that IAM policy, but I can assign any particular of those roles depending on my requirements to my users, to my groups, to my identities, and assign them to any level of the hierarchy that we have seen. So primitive roles, this is what I've talked about, is very, very kind of cool, very, very broad. I can assign them to all the resources in my project. We've got owner, editor, and viewer. And I got predefined roles designed to map to, like it says here, to job functions. So you will have a networking guy or security guy, or you just give them those permissions based on those roles. This is an example of an instance admin with a set of permissions that what they can do in there. So if I'm just bringing my laser pointer here. So like I said, if I don't want somebody with to delete anything, I can use this role and create some kind of a custom role from that and remove that permission from that role and be able to use it. There is also what we call the predefined browser role, which will basically give you the ability to browse the hierarchy. So you won't be able to see any data or edit any, to see any kind of resources inside those that are creating project, but you'll be able to see the hierarchy. What is the organization? What are the folders? What are the projects that I have? Which kind of services I have in those projects? Custom roles you can see here. So you can see here a combination of multiple predefined roles. I can bring in permissions from multiple roles and create a custom role precisely for example, a particular team who's dealing just with big data, for example. So I give them Spanner, I give them Bigtable, maybe BigQuery, storage. So if they're dealing just those particular services, I can create a custom role for them just for that. And then IAM policies, this is where I will be binding those roles with users on the resources, and I can apply them, like I said, at any level of my hierarchy, at the organization level, at the folder level or project, or directly into the resource. And see here, I've got policy inheritance, which means anything that apply at a high level will trickle down to all the resources. So if I am a folder owner or an admin, I'll be basically an owner or an admin for all the project or projects and the services that comes under that. And with that, we've got another mechanism in place to give permissions or to restrict something on my organization. So organization policies are a set of constraints or restrictions that I can apply for my organization. And the particular use case for that, or the good thing about them is, let's say if my organization, I've got a policy where I don't want to allow anybody to be able to create a VM with a public IP address, for example. So I'm very, very concerned about security. So I can apply that policy at my organization, and I say, okay, I want to disable anybody being able to create a VM with a public IP, for example. Or I can do anything. So there's a very kind of big list of constraints that I can set. And with that, I can do some kind of exception. So if I want, for example, only my security team, their project, to be able to do such an action, this organization policy, I can do some kind of, like I said, exception for my networking team to be able to do that, or my security and things. So I've got another kind of mechanism to control security in my GCP environment. And these are some examples of the constraints: disable serial ports, disable service creation, trusted image projects, and there is a big list of those as well. So this is kind of on general how to control security and control over my service in GCP. And when it comes to networking, I can do some isolation with network with a couple of mechanisms in there as well. So we've got firewall rules. So with firewall rules, there's from the concept perspective, there's nothing new in there to bring in as a mechanism. And we've got private Google access as well. So the firewall rules apply to networks in GCP. Now, a network in GCP, we call it a virtual private cloud. So if you want to create a network in GCP, you've got a service called VPC, where you can create your network. Inside your network, you create your VMs, you create any infrastructure inside there. Now, one particular thing about VPC in GCP, which differentiates Google from other services, is that you can create one network that spans the globe. Now, in GCP, what are those kind of networking? What is the scope of the network? GCP got like 29 regions across the globe, which means 29 cities across the globe. With each of the regions, they've got 3 data centers connected through a fiber optic network that is so powerful. On the top of that layer of the network, Google have created the software-defined network, where when you create a VPC network, it will sit and will connect all those data centers for you to use. So you can create a subnet in each of those regions. So I can, for example, create a network that spans, create a subnet in the US and a subnet in Australia, and I can get 2 virtual machines to talk to each other. Now, if you are on premises, this is very, very difficult to do. There's a lot of routing. You need to take a lot of networking techniques and switches that need to connect networks in different regions. Even in other cloud providers, that's the case as well. So this is one of the powerful features of the Google network, so the VPC itself. So when it comes to firewall rules, so what I said, an example of creating within the same VPC, creating 2 virtual machines that can talk to each other across the globe. Now, if I don't want those virtual machines to talk to each other, or the communication not go through if they are on the same network, I can use firewall rules to protect that traffic. So the firewall rule is basically, when I create a network, I can apply at 3 levels. I can say, okay, all my VMs on this network, this firewall will apply to them. Or there is a concept of tagging. So I can create a VM, and there is a field in them called tag. I can say, for example, front end, this machine is tagged as a front end. When I create the virtual machine, I can say this virtual machine with this firewall rule is tagged with the front end. So the mapping of the two, that firewall rule will apply to that virtual machine. And there is a third level, which is called service accounts. I can go to service accounts. Is another concept that we can discuss on another day. Just conscious of time in here. So you can see here, firewall rule, again, it sits on that VPC network, is completely distributed globally. So it's not like you're for example, you are configuring an appliance or anything like that. It's completely software defined, which basically saying there's no point of failure. There's no contention of resources that like an appliance that everybody's trying to do the calculation. You can see here, because the firewall is applied at the VM, the calculation itself is done at the leg of the VM, which makes it so powerful into your network, make it globally distributed. So firewall rules, basically what you have, you've got direction saying ingress traffic is coming in or out, sources and destination, obviously, and the protocol and the ports. So which kind of protocol I want to open or I want to not allow, and the action, allow or deny, and then I've got some kind of priority. The priority, basically, if I have two firewall rules that I've created, and they've got the same configuration, but one is saying allow this traffic and the other one is saying deny, then basically what's saying here is this priority number deciding which firewall rule would apply in that case. The other concept of controlling security on the network is what we call private Google API access. So when you have virtual machines in your Google network, the services that we want to talk to from the machine, maybe you have an application on your VM that needs to talk to cloud storage, for example, maybe it needs to talk to BigQuery. No, those services, they sit on the Google network. So in order to access them, I need to access the public IPs of those services. Within GCP, I've got this concept of private Google Google API access, which means I can access those public API, public services on GCP with VMs in my GCP with private IPs, not public IPs, which means I can just tick on my network. I say, okay, this network or this subnet enable private Google API access, and this basically will be resolved to the public IP, but the traffic is all internal on the Google network, which makes it so powerful. So I'm protecting my VMs. Let's say if I talked about those constraints that I talked about earlier, I'm not allowing VMs in my organization to have public IPs. Then how do I access the Google APIs, for example? Then I've got this private Google API. When I tick the box saying, okay, I'm allowing these VMs with private IPs to go to the public APIs of GCP with this concept, with this feature. And this is kind of a screenshot where you enable and disable that. So you will select the subnet and you just on and off being able to do that. So in this example, what you see here, we've got two subnets in here, one with the private Google API access enabled and one without. So the one without, I have to have a public IP in order to access, for example, a Google Cloud Storage bucket. Without it, I won't be able to do that because the subnet, the private Google API access on the subnet is disabled. Whereas in the subnet where I have private Google API access is on, with a private IP, I will be able to access the Google storage buckets in here. Okay, so this probably going to set the scene for VPC Service Controls. So now we talked about my resources being able to control the traffic to them, my VMs, probably my clusters of Kubernetes. Maybe I create a cluster of VMs I can control the traffic on. But in GCP, you've seen when we talk about that shared responsibility model that we talked about earlier, when we are seeing the other services, the serverless services. So how do I control access to those? So if I'm having a Google Cloud Storage bucket, for example, then basically I can't put a firewall rule to block traffic to come into my cloud storage bucket. I won't be able to have a firewall rule to block traffic going out from my BigQuery, because those are serverless services. They sit on the Google network. So how do I control, for example, if I'm working in my project and let's say I've got a contractor working for me, I need to give him full control over my data sets. He's got his own projects. How do I stop him to copy data from my project, because he's got full control, to go out and go to his project? I don't have any firewall rules because these are not VMs. These are services that sits on the Google network. This is what VPC Service Control is all about. So VPC Service Control, it mitigates risks of controlling data coming out from my project, even if you have those cloud IAM roles full access, for example, and it will stop public exposure to private data. So what I will be doing, I will be setting what we call a perimeter around my project, and I will decide who will be able to go out from that perimeter, who is not allowed to that, based on what we call context rules. So this is the trusted parameter that I can put around my project, and then I decide who can go out of that perimeter from inside those serverless services, managed services in GCP. And I extend the communication from that to my data center if I wanted to. So I've got control over those rules that I want to do that. And also, anything coming from internet, I can also decide what kind of device, for example. So if for example, I put in a perimeter around my project for those services, and I just want my company employees to access my data, to be able to copy that data coming out from here or accessing it coming in. So I give them the cloud IAM roles, but I'm going to decide, okay, my company, they all use MacBooks and they use this kind of operating system. And this is the API, the IP ranges that is coming from. And this is the country, for example, the region they're coming from. Anybody else who's not satisfying these 4 rules, I'm not allowing them to go through that perimeter, even if they are, they've got the IAM rules. So if I'm a user, for example, we are here, my company did this perimeter and only allowing people from UAE to access the data. If I am on holidays, even if I'm the owner of that project, if that perimeter rule, if those context rules not allow me, if I am in the UK or the US to access, then I won't be able to access my data. And I can set VPC service controls from the Cloud Console, the G-Cloud command, and there is what we call Access Context Manager APIs as well. So let me maybe bring in a demo in here just to show you how that works. So I'm just going to share this in a second. And I'll show you how that works. Let me see. Can I share this? Maybe I need to go back to stream.